Hello and welcome to our Objective 2.3 notes about special right triangles. Now Objective 2.3 says I can solve special right triangles, and there are two types of special right triangles. There are 45, 45, 90 and 30, 60, 90. So we're going to start with 45, 45, 90 triangles. So 45, 45, 90 triangles can easily be demonstrated if we think of a square where we have a diagonal connecting two corners. All right, so this would be a bisector, an angle bisector. So we would have one right angle and then two angles here that are equal. Okay, so if we have a side length that is x long on our square, how could we figure out how long that diagonal is? Well, we could use Pythagorean's theorem, which tells us that a squared plus b squared equals c squared. And both of our side lengths would be x, so we'd have x squared plus x squared equals c squared, or 2x squared equals c squared. To figure out what c is, to figure out what that diagonal is, I just take the square root of both sides. So I'd have the square root of c squared equals the square root of 2x squared, which would be the same thing as the square root of 2 times the square root of x squared. The square root and the square will cancel each other out, so we are left with just c equaling x times the square root of 2. So that length of the diagonal would be x times the square root of 2. Whatever our two congruent sides are, our hypotenuse would be the square root of 2 times that length. So what angles are created here? Well, this is a 45, 45, 90 triangle. So we have two angles that are 45 degrees and one angle that is 90. We have our right angle here and then our two angles here that are both 45 degrees. That's why they call it a 45, 45, 90 triangle. So notice we have two sides of x length, and then the long side, the diagonal, is this length, this x, times the square root of 2. So let's use what we know to find the values for x and y. So if I look at letter A here, this is my long side. So this is 7 root 2. So I can think of this as x root 2. So what is x then? If this is x times root 2, well, x must be 7. And notice in our 45, 45, 90 triangle, these side lengths are equal. The short sides are equal. So that means y must also be 7. Now what about here? So my short length is 4 root 2, which means the other short length must also be 4 root 2. But how do I find the length of x here, my long side, my hypotenuse? Well, I'd have to multiply 4 root 2 times the square root of 2, right? It's this short side times the square root of 2. When I do that, I would get 4 times the square root of 4. The square root of 4 is just 2, so 4 times 2, which means that x would be 8. What about here? If they give us the hypotenuse, we need to find the side lengths. Now, x and y are going to be equal, but think of this. This is x times the square root of 2. Okay, so we need to figure out what x is, so I would divide by the square root of 2. So 6 root 2 divided by 6 divided by the square root of 2. Now we don't like to leave radicals in the denominator, so I would just rationalize this by multiplying both the numerator and the denominator by the square root of 2. When I do that, I would get 6 root 2 over 2, which can be simplified. 6 divided by 2 is 3. So I would have 3 root 2 as my values for x and y. And my last one here, letter D, my short side is 2, which means my other short side, y, must also be 2. And to find the long side, I just multiply that short side by the square root of 2. And there we go. That's how we can find the side lengths of 45, 45, 90 triangles. Now let's look at 30, 60, 90 triangles. So imagine if we have a equilateral triangle. So if I have a bisector here that splits that right down the middle. So let's say this is side length of x. And now I've created a new triangle. Originally, these were all 60-degree angles, right? This was 60 degrees, this was 60 degrees, and this was 60 degrees. But I've cut that angle in the top here in half. So now this is going to be 30 degrees, this is going to still be 60 degrees, and then of course we have the 90-degree angles here. So we've created a 30, 60, 90 triangle. So let's figure out, they're going to ask us to find the height of the triangle. Well, we can use Pythagorean's theorem again. So if this is side length of x, this section here would be half of that, right? So this would be x over 2. And we need to find our height. We can again use Pythagorean's theorem, but we have to be careful here. One of our sides would be x over 2, so we'd have x over 2 squared, plus h squared, what we want to solve for, equals c squared, x squared in this case. So I want to get h all by itself. So this would be x squared over 4 plus h squared equals x squared. I can subtract x squared over 4 from both sides, okay? So when I do that, I have h squared equals x squared minus x squared over 4. Now, I don't like this fraction here, and I bet you don't either. So let's multiply everything by 4. When I multiply both sides of this equation by 4, I'm going to have 4h squared equals 4x squared minus x squared, right? These 4's would divide out. I'd be left with just x squared. So that means 4h squared equals 3x squared. I want to get h all by itself. I divide by 4, divide by 4. So that leaves me with just h squared equals 3x squared over 4. So I need to take the square root of both of that to get h all by itself. Well, the square root of 4 is 2, right? So I'm going to have here, ooh, this will be fun. I'll have h equals 3x over, root 3 of x over 2. So the height of the triangle, we could say, is root 3 of x over 2. However, there's an easier way to approach this, and I want to show you that using this side over here. Instead of saying that the long side is x, what if we say this short side is x? Well, the relationship here would this be 2x, right? Because it's twice as long here because we split it on this side down here. So we have x here, we have 2x here, and then the Pythagorean theorem becomes much easier, okay? I'm going to do it down here. Let's say we have x squared plus h squared equals 2x squared. So that means that x squared plus h squared equals 4x squared, all right? When we square the 2 and the x, I subtract h squared from both, so I have h squared equals 3x squared, which when I take the square root of, I have h equals x times the square root of 3. So there's two ways to look at it. If they give us the long side, the hypotenuse, we would use this one. If they give us the short side of our 30, 60, 90, we can use this one, okay? Now this is the one that I will most often refer to because I think it's the easiest operation-wise. So let's see what happens when we do some sample problems. So this should say 30, 60, 90. How embarrassing. Okay. So this time they gave us the hypotenuse. So let's think about our relationship here. Our hypotenuse is 4 root 3. Our short side is half of that. So half of 4 root 3 would be 2 root 3. And then to find the middle side, we multiply the short side, 2 root 3, times the square root of 3. So that would be 2 times the square root of 9, which would just become 2 times 3, which is, of course, 6. So that side length would be 6. What if they give us the short side? So in this one, they gave us the short side. We know that the long side, x, our hypotenuse, is twice that length. So that means x must be 10. To find our middle side, y here, we would multiply the short side times the square root of 3. So y would be 5 root 3. Very good. All right, let's look at letter C now. Oh, so this time, the middle side is what they gave us. So let's work backwards a little bit. So to find v, I would divide by the square root of 3. Now, obviously, don't want to leave it like that. So rationalize by multiplying root 3 over root 3, and that would give me v is 5 root 3 over 3. I would double that, all right? If 5 root 3 over 3 is my short side, I would need to multiply that times 2. So 5 root 3 over 3 times 2 over 1 would give me 10 root 3 over 3. And that would be my hypotenuse, my longest side, my side opposite of the right angle. All right, let's do another one like that, where they give us that that medium side, the one opposite the 60-degree angle. So I would need to divide it by 3 to get y. So I'd have 2 divided by root 3. Can't leave my answer like that, so rationalize our denominator, and we would get y to be 2 root 3 over 3. I need to double that, multiply it by 2 to get x, so that would give me 4 root 3 over 3. And there we have it. That's how we can solve 30, 60, 90 triangles and 45, 45, 90 triangles. If you're feeling confident with this, go ahead and look at those practice problems. Otherwise, let's check out the sample problems and get some more experience working with these. This is Mr. Carter signing off. I'll see you next time.